Plaster is a building material used for coating walls and ceilings. Plaster is manufactured as a dry powder and is mixed with water to form a paste when used. The reaction with water liberates heat through crystallization and the hydrated plaster then hardens. Plaster can be relatively easily worked with metal tools or even sandpaper. These characteristics make plaster suitable for a finishing, rather than a load-bearing material. The term plaster can refer to gypsum plaster, lime plaster, or cement plaster. Types: gypsum plaster, or the plaster of Paris, is produced by heating gypsum to about 300 Fahrenheit, cast so for a 2 hours 20 plus heat a cast so for a 0.5 H2O plus 1.5 H2O. When the dry plaster powder is mixed with water, it reforms into gypsum. The setting of unmodified plaster starts about 10 minutes after mixing and is complete in about 45 minutes. But not fully set for 72 hours. If plaster or gypsum is heated above 392 Fahrenheit, anhydrite is formed, which will also reform as gypsum if mixed with water. A large gypsum deposit at Montmartre in Paris led calcined gypsum to be commonly known as plaster of Paris. Plasterers often use gypsum to simulate the appearance of surfaces of wood, stone, or metal, on movie and theatrical sets for example. Nowadays, theatrical plasterers often use expanded polystyrene, although the job title remains unchanged. Plaster of Paris can be used to impregnate gauze bandages to make a sculpting material called mudrock. It is used similarly to clay, as it is easily shaped when wet, yet sets into a resilient and lightweight structure. This is the material that was used to make classic plaster orthopedic casts to protect limbs with broken bones, the medical use having been partly inspired by the artistic use. Set mudrock is an early example of a composite material. Technical details: depending on the temperature and duration of the heating process, gypsum converts to the hemihydrate or an anhydrous form. Two polymorphs are known of the hemihydrate. The anhydrous calcium sulfate occurs in three forms, called anhydrite I, II, and III. Each form hydrates differently. The hemihydrate converts to the dihydrate. The anhydrite III converted via the hemihydrate, whereas anhydrite II is converted directly into dihydrate without forming intermediates. Lime plaster. Lime plaster is a mixture of calcium hydroxide and sand. Carbon dioxide in the atmosphere causes the plaster to set by transforming the calcium hydroxide into calcium carbonate. Whitewash is based on the same chemistry. To make lime plaster, limestone is heated to produce quicklime. Water is then added to produce slaked lime, which is sold as a wet putty or a white powder. Additional water is added to form a paste prior to use. The paste may be stored in airtight containers. When exposed to the atmosphere, the calcium hydroxide very slowly turns back into calcium carbonate through reaction with atmospheric carbon dioxide, causing the plaster to increase in strength. Lime plaster was a common building material for wall surfaces in a process known as lath and plaster, whereby a series of wooden strips on a studwork frame was covered with a semi-dry plaster that hardened into a surface. The plaster used in most lath and plaster construction was mainly lime plaster, with a cure time of about a month. To stabilize the lime plaster during curing, small amounts of plaster of Paris were incorporated into the mix. Because plaster of Paris sets quickly, retardants were used to slow setting time enough to allow workers to mix large working quantities of lime putty plaster. A modern form of this method uses expanded metal mesh over wood or metal structures, which allows a great freedom of design as it is adaptable to both simple and compound curves. Today this building method has been partly replaced with drywall, also composed mostly of gypsum plaster. In both these methods a primary advantage of the material is that it is resistant to a fire within a room and so can assist in reducing or eliminating structural damage or destruction provided the fire is promptly extinguished. Lime plaster is used for frescoes, where pigments, diluted in water, are applied to the still wet plaster. USA and Iran are the main plaster producers in the world. Cement plaster. Cement plaster is a mixture of suitable plaster, sand, Portland cement and water, which is normally applied to masonry interiors and exteriors to achieve a smooth surface. Interior surfaces sometimes receive a final layer of gypsum plaster. Walls constructed with stock bricks are normally plastered while face brick walls are not plastered. Various cement-based plasters are also used as proprietary spray fireproofing products. These usually use vermiculite as lightweight aggregate. Heavy versions of such plasters are also in use for exterior fireproofing, to protect LPG vessels, pipe bridges and vessel skirts. Cement plaster was first introduced in America around 1909 and was often called by the generic name adamant plaster after a prominent manufacturer of the time. The advantages of cement plaster noted at that time were its strength, hardness, quick setting time and durability. Heat-resistant plaster. Heat-resistant plaster is a building material used for coating walls and chimney breasts. Its purpose is to replace conventional gypsum plasters in cases where the temperature can get too high for gypsum plaster to stay on the wall. Heat-resistant plaster should be used in cases where the wall is likely to exceed temperatures of 50 degrees Celsius. Uses: in architecture. Plaster may also be used to create complex detailing for use in room interiors. These may be geometric or naturalistic. These are also often used to simulate wood or stone detailing found in more substantial buildings. In art. Many of the greatest mural paintings in Europe, like Michelangelo's Sistine Chapel ceiling, are executed in fresco, meaning they are painted on a thin layer of wet plaster, called intonaco. The pigments sink into this layer so that the plaster itself becomes the medium holding them, which accounts for the excellent durability of fresco. Additional work may be added a secco on top of the dry plaster, though this is generally less durable. Plaster may be cast directly into a damp clay mold. In creating this piece, molds or waste molds would be made of plaster. This negative image, if properly designed, may be used to produce clay productions, which when fired in a kiln become terracotta building decorations, or these may be used to create cast concrete sculptures. If a plaster positive was desired, this would be constructed or cast to form a durable image artwork. As a model for stone cutters, this would be sufficient. If intended for producing a bronze casting, the plaster positive could be further worked to produce smooth surfaces. An advantage of this plaster image is that it is relatively cheap. Should a patron approve of the durable image and be willing to bear further expense, subsequent molds could be made for the creation of a wax image to be used in lost wax casting, a far more expensive process. In lieu of producing a bronze image suitable for outdoor use, the plaster image may be painted to resemble a metal image. Such sculptures are suitable only for presentation in a weather-protected environment. Plaster expands while hardening, then contracts slightly just before hardening completely. This makes plaster excellent for use in molds, and it is often used as an artistic material for casting. Plaster is also commonly spread over an armature, usually made of wire, mesh or other materials, a process raised details. For these processes, limestone or acrylic-based plaster may be employed. In medicine, plaster is widely used as a support for broken bones. A bandage impregnated with plaster is moistened and then wrapped around the damaged limb, setting into a close-fitting yet easily removed tube, known as an orthopedic cast. Plaster is also used within radiotherapy when making immobilization casts for patients. Plaster bandages are used when constructing an impression of the patient's head and neck, and liquid plaster is used to fill the impression and produce a plaster bust. Perspex is then vacuum formed over this bust, creating an immobilization shell. In dentistry, plaster is used for mounting casts or models of oral tissues. These diagnostic and working models are usually made from dental stone, a stronger, harder and denser derivative of plaster which is manufactured from gypsum under pressure. Plaster is also used to invest in flask wax dentures, the wax being subsequently removed by burning out, and replaced with flowable denture base material. The typically acrylic denture base then cures in the plaster investment mold. Plaster investments can withstand the high heat and pressure needed to ensure a rigid denture base. In orthotics and prosthetics, plaster bandages traditionally were used to create impressions of the patient's limb. This negative impression was then, itself, filled with plaster of Paris, to create a positive model of the limb and used in fabricating the final medial device. In addition, dentures are made by first taking a dental impression using a soft, pliable material that can be removed from around the teeth and gums without loss of fidelity and using the impression to creating a wax model of the teeth and gums. The model is used to create a plaster mold and the denture materials are injected into the mold. After a curing period, the mold is opened and the dentures are cleaned up and polished. In fire protection, plasters have been in use in passive fire protection, as fireproofing products, for many decades. The finished plaster releases water vapor when exposed to flame, acting to slow the spread of the fire, for as much as an hour or two depending on thickness. It also provides some insulation to retard heat flow into structural steel elements, that would otherwise lose their strength and collapse in a fire. Early versions of these plasters have used asbestos fibers, which have by now been outlawed in industrialized nations and have caused significant removal and recoating work. More modern plasters fall into the following categories: fibrous, cement mixtures either with mineral wool or with vermiculite, gypsum plasters, leavened with polystyrene beads, as well as chemical expansion agents to decrease the density of the finished product. One differentiates between interior and exterior fireproofing. Interior products are typically less substantial, with lower densities and lower cost. Exterior products have to withstand more extreme fire and other environmental conditions. Exterior products are also more likely to be attractively tooled, whereas their interior cousins are usually merely sprayed in place. A rough surface is typically forgiven inside of buildings as dropped ceilings often hide them. Exterior fireproofing plasters are losing ground to more costly intromescent and endothermic products, simply on technical merit. Trade jurisdiction on unionized construction sites in North America remains with the plasterers, regardless of whether the plaster is decorative in nature or is used in passive fire protection. Cementitious and gypsum-based plasters tend to be endothermic. Fireproofing plasters are closely related to firestop mortars. Most firestop mortars can be sprayed and tooled very well, due to the fine detail work that is required of firestopping, which leads their mix designers to utilize concrete admixtures that enable easier tooling than common mortars. In industry, it is used in glass making, tanning, bleaching powder making and purification of sugar. Safety issues: the chemical reaction that occurs when plaster is mixed with water is exothermic in nature and, in large volumes, can burn the skin. In January 2007, a student sustained third-degree burns after encasing her hands in a bucket of plaster as part of a school art project. The burns were so severe she required amputation of both her thumbs and 6 of her fingers. Some variations of plaster that contain powdered silica or asbestos may present health hazards if inhaled. Asbestos is a known irritant when inhaled in powder form and can cause cancer, especially in people who smoke, and inhalation can also cause asbestosis. Inhaled silica can cause silicosis and can encourage the development of cancer. Persons working regularly with plaster containing these additives should take precautions to avoid inhaling powdered plaster, cured or uncured. See also. References. External links.